somehow understanding goes beyond knowing. But how? Clues can be found in this fantasy. Imagine a snowball fight in space. Half a dozen astronauts in free fall arrange themselves in a circle. Each has in hand a net bag full of snowballs. At the word go over their radios, each starts to fire snowballs at the other astronauts. What will happen? What is your prediction? If you have some understanding of Newton's theory of motion, you may predict that this snowball fight will not go very well. As the astronauts fire the snowballs, they will begin to move away from one another. Firing a snowball forward pushes an astronaut backward. Moreover, each astronaut who fires a snowball will start to spin with the very motion of firing, because the astronaut's arm that hurls the snowball is well away from the astronaut's center of gravity. It's unlikely that anyone would hit anyone else, even on the first shot, because of starting to spin, and the astronauts would soon be too far from one another to have any chance at all. So much for snowball fights in space. Understanding a topic of study is a matter of being able to perform in a variety of thought-demanding ways with a topic, by making explicit what has been implicit. For instance, to explain, muster evidence, find examples, generalize, apply concepts, analogize, represent in a new way. Suppose a student knows Newtonian physics. The student can write down equations and apply them to 3 or 4 routine types of textbook problems. In itself, this is not convincing evidence that the student really understands the theory. The student might simply be parroting the text and following memorized routines for stock problems. But suppose the student can make appropriate predictions about the snowball fight in space. This goes beyond just knowing. Moreover, suppose the student could find examples of Newton's theory at work in everyday experience. The more thought-demanding performances the student can display, the more confident we would be that the student understands. Understanding something is a matter of being able to carry out a variety of performances concerning the topic. Performances like making predictions about the snowball fight in space, and show one's understanding, and at the same time advance it by encompassing new situations. We call such performances understanding performances, or performances of understanding. Final stages of the construction of the Space Labyrinth project call for close alliance with peers. Fitting of all the various modules into one cohesive design requires the use of several tools, including the glue gun. Division of labor is necessary to complete the project. Students are excited as the project nears completion. Many choose to airbrush their pieces. The students' sense of achievement and accomplishment is obvious as they admire each other's beautifully designed and carefully executed projects. These space labyrinths are a visual culmination of the study of geometry in the 8th grade. David Perkins continues and clearly explains the purpose of the 8th grade curriculum. Learning for understanding requires not just taking in what you hear, it requires thinking in a number of ways with what you heard, practicing and debugging your thinking until you can make the right connections flexibly. This becomes an especially urgent agenda when we think about how youngsters typically spend most of their school time and homework time. Most school activities are not understanding performances. They are one or another kind of knowledge building or routine skill building. Knowledge building and routine skill building are important, but if knowledge and skills are not understood, the students cannot make good use of them. Teaching for understanding is much more than a matter of method, of engaging students in understanding performances with frequent rich feedback, powerful representations, and so on. Besides method, it is also a matter of content, thoughtful selection of content that proves genuinely generative for students. If we teach within and across subject matters in ways that highlight powerful conceptual systems, we will have a connected curriculum, one that equips and empowers the learners for the complex and challenging future they face. Teachers are all too aware that their students often do not understand key concepts in science, periods of history, works of literature, and so on nearly as well as they thought they might. And most teachers are concerned about teaching for understanding. They strive to explain clearly. They look for opportunities to clarify. From time to time, they pose open-ended tasks such as planning an experiment, interpreting a poem, or critiquing television commercials that call for and build understanding. While concerned about teaching for understanding, most teachers distribute their effort more or less evenly over that and a number of other objectives. Relatedly, the institutions within which teachers work and the tests they prepare their students for often offer little support for the enterprise of teaching for understanding. In other words, as Theodore Sizer and many others have urged in recent years, better education calls for a simplification of agendas and a deepened emphasis on understanding. This, in turn, demands some restructuring of priorities and of schedules and curricula that work against teaching for understanding. The following exhibit at St. John the Divine was executed by Cooper Union and Pace University students. It is on permanent display. This exhibit inspired the 8th grade Labyrinth project.